So this is going to be the first of a series of videos on graphing multiple transformations from a parent function. And so what is usually a wise idea when you're graphing these is let's identify the parent function. So the parent function of this would be y equals the absolute value of x. And so the parent function is just, if you strip away all of these stretching, flipping, shifting, what's left, and that's going to be the absolute value of x. And so in order to see how these transformations are going to happen, let's start by making a table for the parent function and graphing that. So I'm going to make an xy table, and usually on parent functions, not always, but usually you're going to choose -2, -1, 0, 1, and 2 for our x values. There are some exceptions to that, and I will show you one in another video, but in this video, this parent function is going to be wise to choose those. And so if we do the absolute value of -2, that's 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So let's graph these. We've got -2, 2. -1, 1. 0, 0. 1, 1. And 2, 2. And you can connect the dots, and this will continue on forever in both directions here. And so we've got this V-looking shape. So let's talk about, oops, that's not what I wanted. Let's grab all of this stuff. There we go. Let's pull this down here and let's make a table for this one. And so when we make a table, we are not going to do -2, -1, 0, 1, and 2. And the reason why is because this is not going to give us that V shape. So let's be smart about what numbers we're going to choose for x. And what's going to help us figure out what we choose for x is looking at what's inside that function, that x minus 4. And what makes that 0. So what I'm going to do is I'm going to put in 4 for x. Because if we have x equal 4, then we have 4 minus 4, that's 0. 0 times -1/3 is 0, plus 5 is 5. And so that's going to be one of our points on this one. And if you understand transformations, that shouldn't be too complicated for you. You know this is a shift to the right 4 and up 5. So right 4, up 5, that's going to put us right there. That's going to be our new vertex for this one. And I don't need those lines. I'm going to get rid of those because they're going to be in the way a little bit later. There we go. And then usually what we'll do then is we'll pick a couple numbers below 4, like 2 and 3, and a couple numbers above 4, like 5 and 6. But we're not going to do that for x. And the reason why, and maybe it's best to just give you an example here, is I'm going to do 7 for my next x value. And so if I do 7 minus 4, that's 3. The absolute value of 3 is 3. And then 3 times -1/3 is -1. And so you notice how I picked 7 so that the stuff in the absolute value gives me a multiple of 3. So when I multiply it by -1/3, I get a nice integer value or whole number. In this case, it'd be an integer. And so what we're going to do is we're going to pick numbers that are going to give me multiples of 3 to cancel out that 1/3. All right, so back at it. 7 minus 4 is 3. Absolute value, that's 3. 3 times -1 is, or times -1/3 is -1. Plus 5 is 4. And then I'm going to go up another 3, so this will get me to 10. 10 minus 4 is 6. The absolute value of 6 is 6. 6 times -1/3 is -2. -2 plus 5 is 3. So then we're going to keep going on this trend. We're going to go to 1. 1 minus 4 is -3. The absolute value of that is +3. 3 times -1/3 is -1. -1 plus 5 is 4. And then we're going to keep going in the same trend. So we're going to go to -2 because we just keep going down 3 each time we go to the next number. So -2 minus 4 is -6. Absolute value of that is 6. 6 times -1/3 is -2. Plus 5 is 3. So we have a bunch of points here that we're going to graph. we've got -2 up 3. We have 1 up 4. We have 4, 5. I've already graphed that one. We have 7, 4. And we have 10, 3. So if we graph this, we should be able to see all of those transformations happening. It was over 4 up 5, kind of like we said, over 4 up 5. And it was flipped upside down. That negative out in front of the 1 in the 1/3 flipped it upside down. And then this was actually, sometimes it's hard to tell, especially with this function, but this was a vertical compression. So what that means is it pushed the graph in by a factor of 1/3. So that 1/3 out in front is a vertical compression by a factor of 1/3. And so what that means is, instead of, I'll try to erase some stuff so I can explain this here. If you notice on the pink graph, the parent function, this graph, we'll fill that in again. To get to the first point, we went over 1, up 1. Well, on this yellow graph, we go over 1 and then down 1/3. And that's because it was pushed vertically by a factor of 1/3. And so every time you would go over 1, up 1 on the pink one, you'll go over 1, up 1/3 on the new graph, on the offspring function. And so really, you don't even need that table. If you get how these transformations work, you don't have to make a table. You can just say, well, I go over 4, up 5. And then it's flipped upside down, so I know it's got to go down. And then instead of going over 1, down 1, I'm going to go over 1, down 1/3. Instead of going over 3, down 3, I'm going to go over 3, down 1. And so this helps us. We don't really, like I said, we don't even need the table if you get how all these transformations work. The table's nice as a fallback or as you're learning this, but then as you get more adept at doing this stuff, you're going to be just fine without the table. So there's the first example. We'll go over 2 more examples that are different parent functions, and hopefully you learn a little more in these next 2 videos.